Hi guys, welcome to the channel. In this video I'm going to use PySpark to solve an interview assignment I had in the past. In the interview I was asked to use Pandas, not PySpark, but I thought, why not try using PySpark and solve the same problem? It's not big data, but it was a good exercise to perform PySpark transformations, so if you want to learn PySpark, it's a good exercise. As you can see on my screen, this CSV file has several columns: the ID column, the pack size text, pack size, item value, item density, item weight, and the total weight. So as you can see, we have data in some of the columns, in some of the rows, and in some of the columns. And the goal here is to calculate the total weight where it's empty. There are several approaches and many ways of doing the same thing and achieving the same result. My approach was to check if the pack size text is not empty, then split the text, get the numbers and multiply them together. So here that would be 5 multiplied by 1 equals 5. Here 6 multiplied by 3, it's 18, etc. etc. If we don't have pack size text, then there are two ways of calculating the total weight. One is to multiply pack size with item weight. So for example, here again, you will see if we multiply 5 with 1, we will get 5. Here in record 10, if we multiply 3 with 1, we will get 3 as total weight. But what happens if there is no item weight, like here, like in the last record? So we have to multiply pack size with item value and item density, and that would give us the total weight. So let's dive into the code and see how I approach the issue. Okay, so the first thing we need to do is to import the Spark session from PySpark.sql, because we're going to use PySpark as we said, and then create a Spark session by using Spark session.builder.appname. You provide whatever name you want, .get or create, and that will give us a Spark session. The second thing is to provide a path with our CSV file. So here I provide the path to the CSV file in our main function, and in the main function I use another function called load CSV, and I provide the path. And here we have this load CSV function. We get the path and we provide it to Spark, so we can read it as a PySpark data frame. We can do that by using spark.read.option header true, because we have headers in the CSV file, and we provide the path. That would return us a PySpark data frame. Nothing fancy here, we just load the CSV file. So let's move on to the next function, which is the populate total weight, and this is where we perform the transformations in the PySpark data frame. Now let's go step by step, because that's a lot actually to absorb. Let me use this. Let me actually comment this out, and I will tell you why in just a moment. And let's say we want to print the first rows false. We don't want to truncate the columns. So what I do here is I create a new column called total weight 2. You can name it whatever you want. And here we take the data frame dot with column. We provide a new column name, and then using a when statement. Now, when statement in PySpark is the case when statement that we have in SQL. It's exactly the same thing. And here we provide the first parameter is the conditions. So we say if the total weight is empty, because if the total weight is not empty, we don't have to do anything. The total weight is already calculated. And then we check if the pack size text is not empty. We are going to get the numbers from this text. So the first thing we need to do is split the text based on space. Now let me run this and see what happens if we split the text. We will get a list with all the elements that is inside the text. Here, as you can see on my terminal, you will see the same text here, but split into elements inside the list. We want the 6 and the 3, not these words here, boxes or off or kg. We want only the numbers, and that's why I created a user-defined function to get those numbers. Here it is. I say if the array, I just use ARR as the parameter. So if this row here is not none, because you can see we have null in some records. So if we have data, then inside the list comprehension, what we do is for x in this array, if x is digit, that means if x is a number, is an integer actually, not a float, but an integer. That's why this is how you check if a string is actually a number, an integer. Then we convert the string into an integer. Of course, as you can see, I'm using lambda function here. I could use a regular function. I just use lambda function and I pass as a parameter the array. So for each record here in the data frame, if this total weight column is not none, so if we have a list with data, then we check if it's a number, so 6 is a number, then we convert the string into an integer, because 6 here is a string, and then we're going to convert it into an integer. Otherwise, we will not be able to multiply those numbers in string format. We want them as integers. Now, in the user-defined functions in PySpark, as you can see, you can define your own Python function and you convert it into PySpark function, user-defined function, and you can use it to apply transformations to PySpark columns. Because if you don't use user-defined functions, you will not be able to apply the same transformations using Python. And this is a very actually convenient way to use user-defined functions. It solves a lot of issues because you can use straight up Python. Now in the user-defined function, you can also pass the return type. Here I used to pass the parameter, the array type as integer. The array type, that's the return type, array type. It would be like an array type that contains integers. But the problem with that here, if you return that, is if you have a float, it's not going to return it. But in this case, we want also, if it's a float, if that was 6.5, we would also want the 6.5 to return. So if you give like a return data type, so array type, and that contains integer types, that would cut all the flows. It will filter out all the floats. And you don't want that. You want to return whatever number there is, whether it's integer or float. You just want all the numbers. So let me remove that. And conversely, if you use float type here instead of integer type, then it's going to filter out all the integers. That, again, you don't want that. So let's remove that, save that. And here we defined a user-defined function in PySpark, and I'm using this UDF1 here in the case when statement. So what we do is apply the function into the column we want. And here we pass as a parameter in the user-defined function this list after the split has taken place, and we get back the numbers. So let me run this. I will show you what I mean. Yeah, it takes a bit of time. So here we got a list with only the numbers. So 6 and 3, 6 and 4, 4 and 3. And now we are able to multiply those numbers and calculate the total weight. Again, I'm using another user-defined function. And here, as you can see, instead of a lambda function, I created my own function here called multiply array items. I pass the array list and I check if it's not none, if the array is not none, then use reduce and lambda function. The reduce function is coming from the functools library. You have to import it. And what it actually does is to apply a particular function, here a lambda function. Here we pass two parameters and we multiply those parameters. And it applies a particular function to all the elements of a list, this list here that we pass. So for instance, now that we pass this list with 4 and 3, it's going to take 4 and 3 as the first two parameters and multiply them together. Now, what happens if we have a bigger list? So if we have a list with 3 or 4 elements, let's say we have this list. Now it's going, in the first iteration, it's going to take these two parameters, the first two parameters, it's going to multiply them, or whatever else you have, performed here as an action, and it's going to give us 12, right? And then it's going to give the result that we obtained and multiply the result with the next parameter. So it would multiply 12 with 1, and that would give us 12, and then it's going to multiply this result with the next element in the list, that would be 5. So it's going to give us 5 multiplied by 12. This is what the reduce function does. It's very useful when you perform calculations. I really like it. And the next step is to pass this function, the multiply array items, here and define it as a user-defined function in PySpark. Because we are going to use this user-defined function, we are going to apply this function to this column. So if we do that, let me show you what we are getting back, and that would be actually the result from the multiplication in the total weight column. Let's see. And still running. Okay, here we are. We get these results. So if we multiply 6 with 3, then we get 18. If we multiply 6 by 4, we are getting 24. 4 by 3, we're getting 12, right? So it returned the total weight that it's coming from the pack size text column. What happens if we don't have data in the pack size text column? So here, for example, we don't have data. Here we don't have data. And in the last two records, we don't have data. Now, remember, the second case when statement would be to check whether the pack size has data and the item weight also has data. And then if they both have data, if both columns have data, then we multiply them together. That could be the second when statement here. So we check when the total weight is null, of course, so it's empty, and the pack size is not empty, and the total weight is not empty as well, then we multiply those two columns together. It's pretty simple, a case when statement. Exactly the same happens with the third case. So if the total weight is null again, if the pack size is not empty, so we need pack size, and then we check if the item weight is empty and we cannot actually use this column. We have to use item value and item density. So we are going to multiply those three columns here: pack size, item value, and item density. And then otherwise, which is like the else in the case when statement in SQL, that's the else, then we just put whatever the total weight column has. Let me run this and I will show you what we get after all those transformations. And that would be actually the results. Let it give it a minute, please. Yeah, here we have the total weight column 2. It contains all the data for each record. It has the total weight. We have calculated the total weight based on all these columns: pack size text, pack size, etc., etc. So we filled this column as requested in the requirements, and now you can see that we have here float numbers, although they are integers, right? Now, one trick before I continue with that, I will show you that if you want to convert everything into float type in PySpark, you just do this. So the data frame, in the data frame you have df2 in this case, dot with column. You select the column you want to cast, and then you perform a cast here as float type. So you need to do df data frame dot total weight, the column, dot cast, and pass the data type that you want, float type or integer type or string type or whatever, because now it's this column is in string format. And then if we do a dot show and print also the schema, you will see it has different data type. Let's run this. After casting the column into float, give it a second, and here we are. So it casted everything into float type, if this is what you want. And here in the schema you can see this column is of type float. This is how you cast a column in PySpark. It's pretty simple. Okay, so we are good to go. We have populated the total weight column, so everything is alright. Now the problem is this code is not extremely generic. What happens if here in the text, in the pack size text, we had like a float number 3.3 or 4.2? Well, it could be a problem, right? Let me show you if I change that in the CSV file and put a float number instead of an integer. It would not pick up the float number. And the reason is it's not going to pick it up because here, first of all, we are using if x is digit. That means that gives us if a string is an integer, it doesn't. If it's a float, it returns false. So what can we do now? And then we convert into integer, not a float, even if we passed this condition. What are we going to do for that? Well, let me show you. If I change the numbers in the CSV file, so if I run this now, you will see we are not going to get the expected results. It's not going to bring back the float number. Here you see we have in record 4, 6 as a total weight because it didn't bring back the 3.3, or here the 1.5. So it gave only 5 because it picked up only the first number, that it's an integer. So how can we solve this issue? It's quite interesting actually. So the first thing to check is here in the user-defined function for x in the array. If x is digit, then convert it to integer. So if x is digit equals true, that means it is an integer, then convert it to integer. Else, we have to check if x actually is float x, then we return float, we convert the string into float, else none. Now, the first thing we need to specify here is the isFloat function. That's our function. So how can we do that? With try and except statement, float x except value error. If it's an exception, return false, else return true. Return true. My keyboard is not working properly, sorry about that. Return false. So there is no such thing as checking if the string is a float in Python, so we have to define our own function here and convert the number in a string into float. If it converts, then we return true. If it doesn't, so if it's not a float, then we return false. And this is the function we use here in the list comprehension in the else statement. And if it is a float, then convert it to float, else none. Now, if you noticed, before I had the for loop here and then the if statement, right? But now I moved the if statement on the other side before the for loop. And this is how it works. So if you don't use an else statement, you put the if statement after the for loop. If you are using an else statement in the if statement, then you have to put the if statement before the for loop. It's quite, yeah, it took me some time to learn that in the past, but this is how it works. So if we, now that we have updated this user-defined function and we apply that here, let me remove the user-defined function 2 for a second and the rest case when statements that we don't need right now, and this one as well, and this one as well, and let's see what this change brings back, right? So let's see, now that we have a float number in the text, let's see what we are getting back with this change that we just implemented. And you see we are getting a list with all these with the numbers and the float numbers, but also we are getting nulls. And this is because in the else statement we have to use none. We just use none because we don't want anything to be put there, but also because we have to use else, right? If I remove the else statement here, that could give me a syntax error, so I have to use else here and use none. And the next step here is if we try to multiply, use the user-defined function 2 and multiply the numbers, it's going to give us an error because it's going to multiply 6 multiplied by 6 with null, it's going to give an error. So what needs to be done here is actually to apply a filter. So it's going to filter out all the false values, and filter takes a function as a parameter. So let's use a lambda function here and say x is not none, and here we pass the array as a parameter, and two brackets. And now it's going to filter out all the false values. So if we are going this way, we are going to remove all the null values and keep only the numbers on this list. And since filter is going to return, since filter is returning a generator, we have to convert the generator in a list. So that's how we are getting the values. And if we apply the user-defined function to here, and see what this brings back, in theory it should be bring back the total weight and multiply the integer with the float numbers and give us the total weight regardless if it's an integer or a float. So here, as you can see, we are getting a float number because it multiplied 6 with 3.3. We are not getting anything for the second record because the total weight already exists. So we are not going to perform anything on this record. So it was a bad choice to change the kilos here. Sorry about that. Let me change that back to 1. However, we were able to actually multiply 6 with 3.3, and with those changes that we applied in these user-defined functions, first we used an else statement here. We checked if the string is float, then convert it to a float. Otherwise none, and if it's an integer, convert it to an integer. And then we filter out the none values and we perform the multiplication. Great. Let me uncomment the rest of the code and see what it brings back us. And let's see what the total weight looks like after all these changes for all the records, of course. And here you see we populated the total weight as expected. We have float numbers here, but we also have integer numbers, and we have integer numbers that are being displayed as floats. Let's say that someone wants the integer numbers here to be displayed as integers and not as floats. And here that would be 24, and here it would be 3, and here it would be 34. We have to remove the dot zeros. Now there are many ways of doing that. You can use regex expressions, but I'm going to use a user-defined function here, and that would be, let's say, a lambda function, and we have to check if is instance x is instance of float and x dot is integer. Now we check if it's a float, it's if the data type is float, but it's an integer number, so is integer, it's coming from Python, straight up from Python. It checks if a float is actually an integer and not a float, then we can convert the float into integer, else we just leave it as it is. And if we apply this user-defined function now here in our columns, and you will see user-defined function here as well, and closing the bracket and here, and let me run this again, and that would convert the float numbers that are actually integers into integers. Is there any purpose of doing that? On doing that? Maybe not, maybe yes, maybe the BI developers want this kind of format. It happens pretty often, if you ask me. And here you will see now that we have integers, float numbers as float numbers, and this float number became an integer as it is actually an integer, and 3 here and 24 here. The total weight is a string. Now this column is still a string, that's why we can keep this format. I believe we are good to go now with these results. I'm going to upload the CSV file and the code to GitHub. You can play around, save the data in the CSV and see how PySpark reacts to those changes. I think it's a good quiz if you want to learn transformations in PySpark. As I already mentioned, there are many ways to achieve the same results. Feel free to play around and try different things. That is all for this video. I hope you got something out of it. If you like the video, click the like button and subscribe to the channel.